Hello dear students, welcome to a new trigonometry lesson. Today we'll be having a general exercise on Unit 4. And as I always remind you, once you see the question, please pause the video, try to answer the question yourself, and then check your answer after playing the video. Exercise number 1 is to choose the correct answer. In question 1, the question says in the opposite figure, ABC is a triangle in which angle A is 90 degrees, AB is 5 centimeters long, and BC is 13 centimeters long. The question here wants you to find the value of tan B. So, when you go and check for angle B, which is this angle, you will see that AB is the adjacent and BC is the hypotenuse. To find tan B, you need to find the opposite. So, you can easily find AC using the Pythagorean theorem as 13 squared minus 5 squared. So, the length of AC is equal to 12. Then, tan B is opposite, which is 12, over adjacent, which is 5. If you simplify 12 over 5, you will see that it's equal to 2.4. Then, the right choice in this case is choice B. In question 2, the question says, for any acute angle A, what is tan A? We know from the rules that tan A equals sine A over cosine A. So, in this question, the right choice is choice C. In question 3, for any two acute angles A and B, if sine A equals cosine B, then remember that sine an angle equals cosine another angle. So these two angles are what? These two angles are complementary. So when the question asks us to find what's measure angle A plus measure angle B, complementary angles, their sum is 90 degrees. So here, measure of angle A plus measure of angle B is 90. In question 4, if the measure of angle A is 75 degrees and sine B is equal to cosine A, then remember that sine B equals cosine A, then A and B are complementary angles. If A and B are complementary angles, this means that the measure of angle A plus the measure of angle B equals 90 degrees. If we have A is 75 degrees, then B is equal to 15 degrees. So the right answer here is choice C. In question 5, the question says, in the opposite figure, which of the following has the value of sine C? Sine C is the same as, excellent, good job, is the same as cosine B. Let's now move on to exercise 2. In this question, the question is asking us to choose the correct answer. In number 1, 4 times cosine 30 times tan 60 equals what? For sure, this part we're not allowed to use the calculator in. So, we draw the two special right triangles aside, and then we start finding the values. 4 times cosine 30, which is root 3 over 2, times tan 60, which is root 3. You can write it as root 3 over 1 if you want. And then, if you simplify this, it will be 4 times 3 over 2. Then, the answer is 6. So, in question 1, the answer is choice C. Question 2, if cosine 2x equals half. So, you need to check cosine what equals half. You will see that it's cosine 60. Then, cosine 2x is the same as cosine 60, then obviously 2x equals 60, so x is equal to 30 degrees. So the right choice here is choice B. Question 3, and also the two special triangles should be in front of you. If tan 3x over 2 equals 1 and x is an acute angle, so I know that you know it very well that tan 3x over 2 is equal to 1, which is equal to tan 45. Then 3x over 2 equals 45. So 3x is equal to 90. Then x is equal to 30 degrees. Then the measure of angle x is choice B, which is 30 degrees. Question 4. 2 times tan 45, which is 1, minus 1 over cosine 60, which is 1 over half, then it's 2 minus 2, then the answer is 0. So in question 4, the correct answer is choice A. Question 5, in triangle ABC, if the measure of angle A is 85 and sine B equals cosine B, how can we find the measure of angle C? Since sine B is equal to cosine B, then automatically angle B equals 45 degrees, because sine 45 is equal to cosine 45. Then in triangle ABC, if we have that measure of angle A equals 85 degrees and B equals 45 degrees, then the measure of angle C equals 180 minus the sum of 85 and 45. Then the measure of angle C is 50 degrees. So the correct answer here is choice C. Exercise 3. In exercise 3 it says XYZ is a right angle triangle at Z where XZ equals 7 centimeters and XY equals 12 centimeters. Find the value of each of the following. The first thing the question wants us to find is tan X times tan Y. For sure, we need first to find the length of YZ. So YZ equals square root of 25 squared minus 7 squared, then YZ equals 24 centimeters. So now here YZ is 24 centimeters long. To find tan X times tan Y, you need to find tan X. Tan X equals opposite over adjacent, so it's 24 over 7 times tan Y, which is opposite over adjacent, which is 7 over 24. Then the answer is 1. Let's now answer question 2. Question 2 wants you to find sine squared x plus sine squared y. Sine x is the opposite over the hypotenuse, so it's 24 over 25 all squared, plus sine y equals the 7 over 25, and then it's sine squared y, so it's 7 over 25 squared. If you do your calculations, the answer will be 1. Exercise number 4. In the opposite figure, ABC is a right angle triangle at B, in which AB is 9 centimeters, where D belongs to AC and E belongs to BC, where DE is perpendicular to BC and 4DE equals 3EC. The question here wants us to find the area of triangle ABC. Let's now check the givens. We have 4DE equals 3EC. Then EC equals 4 over 3 DE. If you let DE equals x, then EC equals 4 over 3 x. So here we can write DE as x, then the EC is 4 over 3x. In triangle DEC, you will see that tan C equals x over 4 over 3x. So tan C equals 3 over 4. Then if we move now to the big triangle, which is triangle ABC, you will see that tan C is 9 over BC. So 3 over 4 is 9 over BC, then BC equals 9 times 4 over 3, which is 12 centimeters long. Why are we doing all of this? Because the question here is asking us to find the area of triangle ABC. So the area of triangle ABC equals half times base times height, where the base is BC that we got it equals 12, and the height is AB that we have it already equals 9. Then the area of this triangle is equal to 54 centimeters squared. Exercise number 5. ABC is a triangle. Draw AD ray perpendicular to BC to cut it at D. If AB is 13 centimeters, AC is 20 centimeters, and CD is 16 centimeters. Find the value of sine B, cosine C, cosine angle BAD, and tan angle DAC. So, the first thing you do is that you draw the triangle ABC. Okay, so this is triangle ABC. You put the labels. Here's A, here's B, here's C, where AB is 13 centimeters, AC is 20 centimeters, and CD is 16. But where is D? Yes, AD is perpendicular to BC. So this is D, and we have here that DC is 16 centimeters. The question here wants us to find sine B. In order to find sine B and the rest of the requirements, we need to find the length of AD and BD. So let's now find AD equals square root of 20 squared minus 16 squared, which is 12 centimeters, where BD equals, if this is 12 centimeters, then BD equals, Pythagorean theorem as well, 13 squared minus 12 squared, which is 5 centimeters. So now you can easily go and find all the requirements. Sine B equals the opposite, which is 12, over the hypotenuse, which is 13, where cosine C equals the adjacent, 16, over the hypotenuse, which is 12. If you simplify this more, it will be 4 over 5. To find cosine angle BAD, angle BAD is this angle. To find the cosine of this angle, it's the adjacent, that is 12, over the hypotenuse, which is 13. The last requirement is to find tan of angle DAC. Angle DAC is this angle. So tan this angle is the opposite, which is 16, over the adjacent, which is 12. If you simplify this fraction, it will be 4 over 3. By finishing exercise 5, we came to the end of our session. Thank you very much, dear students, and wishing you best of luck.